Welcome to another edition of Admiral Science. I'm your host, Mr. Allen, and today on Admiral Science, we're going to be talking about Intro to Matter. All right, so let's see. What is matter? All right, we have some pictures up here. We have the pictures of some metallic objects like copper, lead, tin, nickel, steel, zinc. Remember from the periodic table, these are all elements found on the periodic table. Alright, then we have gas, liquids, and solids. What could that have anything to do with matter? We have this guy right here, and we have what? Mixtures, compounds, and elements. So what can any of this do with matter? Well, anything that has a mass and takes up space, no matter how large in reference to the eye it may be or how small it may be, if it has a mass and it takes up space, it is considered matter. So what does that mean? Well, any element on the periodic table is matter. All right, it takes up space. Although we may not be able to see a lot of these elements with our naked eye, it still takes up space. All right, it's there. It will not occupy the space with another element or atom. So it takes up space. It is matter. Your body, the human body, and just about any other biological material is matter. Alright, it is made up of matter. It takes up space, it has a mass, it is matter. Any gas, any liquid, or any solid is matter. Alright? If it can be classified as a gas, a liquid, or a solid, it will be considered matter. If it can be classified as a mixture, a compound, or an element, it is considered matter. Alright, matter is anything that takes up space. Alright, the air that you breathe, it is made up of elements that is considered matter. Alright, so here we have the smallest unit of matter. We just got off this topic not too long ago. This smallest unit of matter we know is called the atom. And the atom is the smallest, purest form of matter, purest form of an element. Alright, so, and for extra credit, for those of you who can tell me what element this may be, I'm showing you the nucleus here. If you can tell me what element this may be, I will give you extra credit. Just bring it to me the next day. Alright, and how can we classify matter? Well, matter can be classified because matter is such a wide array of things. Matter can be classified by its physical properties, by its chemical properties, by its state, whether it's a solid, a liquid, or a gas, by its composition, whether it's simply an element, a compound, or a mixture, and you can also classify it by its density, whether it's less dense or more dense than an object. Alright, so today we're going to focus on how to measure matter. Alright, matter can be measured in a variety of ways. Here we have a triangle, and this is what I'm going to have you do in your notes. What I'm going to have you do is I want you to copy this triangle down. And as we go through each part of this triangle, I'm going to come back and reference this triangle, and we're going to add some things that may be associated with this triangle. And as we see here, we have a D, and of course, because we just talked about it, it must mean density. M and V are two that we talked about before, M being mass, V being volume. Alright, so we have a reference to what we're going to be measuring matter by, mass, volume, and density. Alright, so let's first look at mass. Mass is a big part of density, but let's make sure we understand that mass and weight are not the same thing. It is often said that mass and weight mean the same thing. This is not true. Mass is the amount of matter an object has, and it is measured in grams, alright, with a G. And we use a triple beam balance. If we remember, we use a triple beam balance to measure mass. Alright, we use this a couple of times in class, a triple beam balance. Alright, but weight, on the other hand, is a measure of a gravitational force. So it's basically the measurement of the force that is exerted by the object you're standing on. So if you're on Mars, you're going to weigh something differently than you would on Earth. If you're on the moon, you're going to weigh something differently than Mars and on Earth. All right. So weight is a measure of the gravitational force. Mass is just the amount of matter an object has, and this is measured in grams. All right. So depending on where you are, your weight can change. Your mass will not change because of you move location. So if I'm 50 grams on Earth, I'm going to be 50 grams on Mars, and I'm going to be 50 grams on the moon. Now, I may not weigh the same, but I will still measure my amount of mass the same. All right, so then let's skip over density just for a quick second so we can go to volume. Volume is the amount of space that an object takes up or occupies. Objects with well-defined shapes, such as a rectangular box, you can measure length times width times height. All right, and typically with volume, when we measure length times width times height, we use a ruler. And rulers, we know in science we use centimeters. So when we do centimeter times a centimeter times a centimeter, one unit of measurement for volume is centimeters, well, cubic centimeters. All right, but also with a liquid, we know that sometimes we use volume and we measure in milliliters. So volume has two units. It can be milliliters for liquids or cubic centimeters for solid objects. All right. Now these are for well-defined shapes. For irregular shapes like a rock that you find on the ground or something, you want to find the displacement. And what displacement is how much volume does this object have. So you'll take a graduated cylinder, you'll drop the rock inside the graduate. You look at the starting mark here. You'll drop the rock inside the graduated cylinder and count how much it rose up. And because it went from 7 to 9 here, we're going with 2 milliliters, or you can say 2 cubic centimeters. A milliliter and a cubic centimeter are the same thing. So sometimes you'll see milliliter, sometimes you'll see cubic centimeters. There is no difference. Just know that they're the same exact thing. So let's look at density. Density is a measurement of the amount of mass in a given volume. So density is equal to mass, as we just covered, mass over volume. So, or in short form, D is equal to M over V. So let's take a look at our triangle. So we just learned that mass is measured in grams, volume is measured in milliliters or cubic centimeters. So with your triangle, as you filled out your triangle and you with your M, your D, and your V, now above each one you're going to write the unit of measurement. Volume can be either milliliter or cubic centimeters. Mass can be measured in grams. And how this triangle is read is, so we just said that density is equal to mass over volume, or mass divided volume. So let me help you guys out here. I'm going to erase the ink currently on the slide, but make sure you have that the fact that grams is the measurement for mass, milliliters or cubic centimeters is the measurement for volume. So if two items, let's say when you want to find the item of a third, you look at the other two. So if the other two are above each other, or below and above each other, you're going to divide. So if you're looking for density, then you're going to look at the other two, mass and volume, and see that mass is over volume, so you're going to divide. All right. When you look at volume, when you're trying to find the volume, you look at the other two, which is mass over density. So when you want to find the volume, you look at the other two, mass over density, and you're going to divide. But when you're trying to find the mass, you're going to look at the density and the volume. So if they're side by side, you're going to multiply. So up and down, divide, side by side, multiply. All right. So density is over here. When you want to find density, then you're going to divide mass over volume because they're up and down. When you want to find the volume, you're going to divide mass and density because they're up and down of each other. But if you want to find the mass, then you're going to multiply density times volume because they're side by side. So up and down is divide, side by side is multiply. Alright, and now I want you to write the formula for each underneath each letter. So density is equal to M over V. Volume is equal to M over D. And mass is equal to D times V. Alright? So now you have the formula under each triangle. Remember that mass is measured in grams, volume is measured in cubic centimeters or milliliters, either one. And density, its unit of measurement is grams per cubic centimeter or grams per milliliter. Alright? So it's just these two. So for the density, you take both of them. Grams per cubic centimeters or grams per milliliter, depending on which unit you're using, milliliters or cubic centimeters. Alright, so let's do some math. Alright, so here, one of the key components of density is mass. So you'll be able to have to read, this is a triple beam balance. Triple beam balance. And we use these all the time in science class. Alright, so how we read it is we look at the large number, which is 300. The second number, which is 50. The last number, remember each one is a tenth. So 4.1, 0.2, 0.3, 0.4, 0.5, 0.6. So we have 4.6. How did I say 4.6? Because this is the whole number, 4, and each one is a tenth. So 4.1, 4.2, 4.3, 4.4, 4.5, 4.6. Add them up, 354.6 grams. Remember the unit of measurement, grams. Alright, now the volume. Remember, we're going to find the volume, and because we have an irregularly shaped object that you can't easily find the length times width times height of this dinosaur, we're going to do displacement. Displacement is simply you look at the starting point and then you drop the dinosaur in, you look at the ending point, see how much it rose. Alright, so in between the 3 and the 4 there are 4 hash marks. 1, 2, 3, 4. So what would be the hash marks? They're 0.2 or 2/10. So there'll be 3, because if you go by 2s all the way up to 10 or the next whole number, so this is 3, then 3.2, 3.4, 3.6, 3.8, and then 4. 4.2, 4.4, 4.6, 4.8. So the water has started out at 4.8 milliliters, and it rose to, this is 5, 5.2, 5.4, 5.6. Alright? So you see how much it rose. So you take 5.6, subtract it from 4.8. When we do our math, 0.8. So the dinosaur would have a volume of 0.8 milliliters, or you could say 0.8 cubic centimeters. Alright, so now it says find the density of a rectangle. A cube would not have different lengths. So here we have a length of 2 centimeters, a width of 2 centimeters, and a height of 10 centimeters. You place it on a digital scale, and it has a mass of 80 grams. What is its density? So let's go with what we know. So when you do a problem, you want to already identify what you know. So we know the mass is equal to 80 grams. It is said that in the problem, 80 grams. All right. Now we know we're trying to find the volume, which they did not specifically give us the volume, but we know that we can do length times width times height of shapes. All right. So length times width times height. So 2 times 2 times 10. So this turns into 4 times 10, and it goes to 40 cubic centimeters. Remember our units, cubic centimeters. So our volume is 40 cubic centimeters. All right, so we have our volume. So now, do we have all the components? Let's write our formula for density to make sure. So we got density is equal to M over V. All right, so let's plug in our values. Density is equal to our M is our mass, which is 80 grams. Our volume is 40 cubic centimeters. And then when you do the math, it comes out to 2 grams per cubic centimeters. Alright, so now we'll go through some do-it-yourself, find the volume, mass, or density in these practice problems. Alright, pumice is an igneous volcanic rock formed by the rapid cooling of lava. What is the density of a 49.8 gram piece of pumice that has a volume of 83 cubic centimeters? So what do we already know? Let's identify what we know. Alright, the mass is equal to 49.8 grams. Oh, currently I want you to, on the back of the triangle, let's do practice. There are 5 practice problems. So this is practice problem number 1, and I want you to label it as practice problem number 1. All right, 49.8 grams. The volume is equal to 83 cubic centimeters. All right, so and our formula for density is equal to M over V. So when we write in our questions, it goes, our mass is 49.8 grams over 83 cubic centimeters. Plug that into a calculator. 49.8, divide that by 83, and it gets us, if you entered into the correct calculator correctly, 0.6 grams per cubic centimeter. Alright. Next up is practice problem number 2. Take a moment to do this yourself. I'll give you some time. Pause the video so that you can work it out yourself, and then play it back so it's just to check your answer. So obsidian is another type of igneous rock. What is the density of a piece of obsidian that has a mass of 239.3 grams and a volume of 92 centimeters cubed? So what we already know, we know that the mass is equal to 239.3 grams. The volume is equal to 92 cubic centimeters. And we're trying to find out the density. And we know density formula is M over V. Density is equal to 239.3 grams over 92 cubic centimeters. When you density comes out to be 2.60 grams per cubic centimeter. Alright, practice problem number 3. Again, I want you to go back. I want you to pause the video. Then I want you to solve this problem on your own first. Then play and check your answers. Alright, so here it says the basalt rock displaces, keyword here, displaces 16 milliliters of water. The density of the rock is 3.0 grams per cubic centimeter. What is the mass of the rock? So what do we already know? We know the density is equal to 3.0 grams per cubic centimeter. And we said that it displaced 16 milliliters of water. So that's the volume, 16 milliliters. How much it displaced is 16 milliliters. We want to get into the same unit. So 16 milliliters is the same thing as saying 16 cubic centimeters. And that's what we want to stick. We want to stick with, make sure our units are matching up. So 16 cubic centimeters. Alright, and we're trying to find out the mass. Well, if we go back to our density triangle, mass here, volume here, density here. If we're trying to find out the mass, we look at the other two, and we said if they're side by side, you're going to multiply. So you're going to take D times V. Alright, and M is equal to 3 grams per cubic centimeter, my apologies, times it by 16 cubic centimeters. And then you will multiply and get 48. 48 what, Mr. Allen? 48 grams. Alright, because remember we measure mass in grams. And grams is part of here. You cancel out the grams. When you multiply, you're left with the, you cancel out the cubic centimeters. When you multiply, you're left with the G. Alright, so 48 grams for the mass. And you were to work this problem backwards, you would come out with, for the density, 3.0 grams per cubic centimeter. So you can do that for extra credit. Work the problem backwards to where you would get the density of being 3.0 grams per cubic centimeter. So do the formula for density, which is D. So if you're trying to find density, it's M over V. Take this mass, 48 grams, divide it by the volume, which is 16 cubic centimeters, and you're going to come out with 3.0 grams per cubic centimeters. But if you can show me your work and turn it in tomorrow, I will give you extra credit for that. Alright, so here we have a bucket, and it's asking which liquid is the most dense. So let's rank our densities. Alright, so here we have vegetable oil, water with food coloring, some dish soap, corn syrup, and honey. If an object is more dense than another, it's going to sink under. If an object is less dense than the others, it's going to float to the top. Alright, so vegetable oil, of our 5 liquids, vegetable oil will rank number 5 because it's all the way at the top. Number 4 would be water. Number 3 would be dish soap. 2, corn syrup. And 1 would be honey. So honey is the most dense because it's the one at the bottom. When something is denser than another object, it will sink under it. Alright? So water has a density of 1.0 grams per cubic centimeter. Anything that has a density larger than 1.0 grams per cubic centimeter, they're going to sink. Anything with a density of less than 1.0 grams per cubic centimeter, like 0.9 or below, they're going to float above water. Alright, so of course, dish soap, corn syrup, and honey must have a density greater than 1.0 grams per cubic centimeter. Alright, and lastly, this is the last practice problem. Alright, so again, take time, work it out, do it yourself, then play the video, and then check yourself. Alright, a student has 3 objects that are equal in length, width, and height. The first object has a mass of 10 grams, the second object has a mass of 20 grams, and the third object has a mass of 35 grams. Predict which object will be the most dense and which will be the least dense. Justify your answer. Alright, so I'm going to save this one for class. You're going to bring me this answer in class with your justification. Alright? Justify your answers in class, and this will be, again, a part of your homework notes that I will be checking, and then you can also earn yourself some reward for answering this problem on your own. Alright? So, thank you for watching another edition of Admiral Science. Don't forget, if you need to review a topic, if you need to review anything, please stop, pause it, rewind, go back to the part that you did not understand. It is very simple, very easy to understand. Alright? If you need additional help, there are a plethora of websites you can go to, or you can come to tutoring on Thursdays after school. I'm more than available to be there. Alright? So, this has been another edition of Admiral Science. I look forward to seeing you on the next segment. Thank you. Have a good evening.